Basically, when you classify the typical classification, when it comes to typical classification of any automation segment, so you have three typical automations. The very first one is the fixed automation. So fixed automation is nothing but you have a fixed product. Mostly it will be a single product. Okay, just like your Coca-Cola manufacturing. So in Coke production lines, what do you have? It's a single product, but the container size might vary, container type might vary, the bottle size might vary, but it is a simple process, filling. After filling, what they do, they just seal it with some gas followed by capping. Okay, these are some actions that are performed in a fixed automation typically. Okay, the best example is fixed embroidery design is a fixed automation process. Okay, it is generally applied for a major production or a mass production where the modification is very minute. You need not to modify the thing. Your initial investments are pretty much higher, but your production rate is also equally higher. Best example is bottle filling, all those things. So especially in apparel industry, where you can find a fixed automation is rolling, then weaving. These are the two components where excuse me, you don't require much automation changes there. So you have a horizontal line and you have a vertical line. So both things gets weaved up in a machine and you have to roll it. That's a simple automation. But you cannot expect a large variety of products here. Here the product variants are very nominal or limited. Okay. So the next one is programmable automation. In programmable automation, the biggest advantage is you have a low investment. I could say there is some trade-off, but your investments are very much limited. That means in general purpose you fix a robot that can serve 5 machines. You take 5 CNC machines. CNC stands for computer numerical control. So where it produces 5 different parts, but it is handled by a single robot. Okay, but the problem here is it cannot produce a bulk production. Okay, it cannot produce things in bulk. So the best example for this, somebody was telling, programmable design for your apparel or any wearable. Okay, so it is comparatively, it has a lower production when compared to the fixed automation, but you can adapt for a change. For example, if you want to change the product design, so this is more suitable when you are planning to produce an apparel which is of the same material type but with different sizes. It is more suitable thing. Okay, and then it is also suitable for a batch production. Okay, batch production is basically you produce 10 apparels in one batch and another 10 apparels in another batch. So depends, like the material might change, the colors might change, the design might change, but programmable automation is more suitable where you require when you want to work with a market trend. The next one, which is having a trade-off between these both, is fixed automation and programmable automation, is a flexible automation. In flexible automation, you can modify anything. You can modify the design, you can modify the layout, you can modify the product type, you can modify the product variant. Okay, so this is more suitable when you want to have a larger changes that happens in the industry. For the best example is the car industry or any automobile industry. For example, today the market is having BS6 engines. Earlier we used to have BS4 engines. So the engine quality, engine type, engine material, and at the same time engine size, dimensions, everything varies. Okay, so their engine capacity, the weight of the engine, everything changes. So in that case you can apply this typical automation. Whether I should go for a flexible automation or whether I should go for a fixed automation, whether I should go for a programmable automation. You just check this graph. Typically it got 3 segments, low, medium and high in both x and y axis, where if you require the number of parts that are supposed to be high, very huge, in that case, and you require number of parts per year. For example, the best example I have stated is cars. The cars that are sold in India or maybe any typical country depends upon the type of model. There are a lot of factors, safety, etc., etc. Where all these things, when you are considering it for manufacturing, you have to go for a programmable automation, where the production volume will be low, very low. The number of cars that are released in India, especially by Kia, let us say, it will be not more than 20,000. you take the best model, Celtos or something. You take flexible automation, where a fabric industry and apparel industry, where the number of shirt designs in one particular season is limited. You take during summer, the cotton shirts are sold the high because they are very comfortable during that particular season. But during winters, you require a woolen cloth. The same machinery, they perform woolen cloth stitching or maybe manufacturing also, where you require flexible automation. Only certain parameters you have to set in order to produce the thing. Fixed automation is suitable for a common product. You take sugar, it has a fixed automation. You take salt production, fixed automation. Atta, you make, it's a fixed automation. There won't be much changes in it. It produces the same atta, same quality, same thing. At times they might add some additives. Let us say the best example is multi-grain atta. The process is the same, milling process. They mill the grains in order to get you the flour, but the process is the same. They might change the
So
package.
even the textile industry, maybe we can have they have fixed automation.
At times the automation is changeable, like interchangeable, like
Programmable.
programmable.
Yeah.
It can be a flex, it varies again. So the best thing what you get is the flexibility that you have to achieve based on the product that is required as per your market. Okay, you cannot sell all the machines and bring the new layout into picture. You cannot do it. Once the machines are installed, they are supposed to work for 10 to 15 years, are based on the lifespan of that machine. So this fixed automation, variable or flexible automation or a programmable automation is like they'll vary according to the market. So market has a huge impact, right? Now let us start with the next concept, which is levels of automation. Okay, so in industry you take the levels, right? So you have different levels, especially some order will be there. You have your boss will have some boss, and the boss will be actually answerable to the management. So management will have to be a single person or a group of persons, something like that. Similarly, in that chronology, you have different levels of automation. The first one is the device level, where you have your sewing machine or your cutting machine. So that if you are putting some sensors and controlling them, that will becomes a device level automation. Second one is the machine level automation. Machine level is an entire machine, cutting and then transferring the material. That's a machine. So and then cell level. So a cell consists of two or more machines that are automated together. That's a cell level automation. Plant level automation. So you have different plants located at different regions. Certain plants are automated, certain plants are not automated, depending upon the availability of labor, which type of plant they are using, etc., etc. And then interplant level of automation. That means in between two plants there will be some common controller which will do the process. And the next one is the enterprise level, which is on a whole. Okay, so your boss sitting at his cabin, he can visualize what is the device 1 doing at 10 a.m. today. So that hierarchy he can, I mean, that's the level of automation that you could do in an industry. So this is a very important topic. So this will decide what is the cost that is levied on the particular industry or a particular factory or a particular complete industry together. For example, during this pandemic, we have a requirement of some synthetic fabric used for making a mask, let us say. So now what is this enterprise level management will think is, we will go for a device level or maybe a plant level automation, so that within 10 days I will get some 40 crores of masks that are produced which will hit the market. Okay, let us say you assume the third wave is coming now. So it was more anticipatory, so that it might come. So this, what is this, because this mask is one of your, I mean, the apparel industry product only. So what is this enterprise level people will think is, okay, we will do the automation so that it will increase the productivity. So they can do at any level, they can do at a cell level or a plant level or a machine level, but more or less, for especially for this example, a machine level automation would be more than sufficient. So that is how you can define the different levels. What do you mean, what do you understand by strategy? So they perform certain automation strategies. So there are 10 strategies which are very much crucial when you want to go for an automation. First thing is specialization of operations. Is your machine outdated, whether it is whether it is procured almost 30 years back, whether it is really capable of performing a particular operation. If yes, go for it. If the machine is specialized in a or you require a specialized operation, you go for a automation. Until and unless you do not go for it. Combined operations, best example we discussed, cutting and preventing the delamination of the threads, or I mean breaking of the threads. Okay, it happens in one single go. It is a combined operation. Third one is simultaneous operation. Simultaneous means, what is the difference between combined and simultaneous? Any answers? Where you require simultaneous operations, especially in a parallel industry.
So while we saw in the industry before, in the sewing time, we had a under bed trimmer, UBT. So while it was getting stitched, the sides were also getting cut.
So that's a simultaneous operation. You do one particular operation at the same time. The second operation is also required. For example, I'll tell you, folding, when you just stitch two fabrics together. So you require folding and stitching, right? Folding is one operation, stitching is another operation. You take another thing like cutting and trimming of, somebody was telling, I mean trimming of the edges, okay, or after stitching you remove the thread automatically, the additional threads that are coming in. So that is another operation. Integration of operations. Integrate means, integration of operation. You take a sari. So sari has how many typical threads that are associated in one single operation while weaving itself in order to get the design, right? So increased flexibility. What is this increased flexibility? So increased flexibility in the sense, see, you have one single product that is being generated every 10 minutes, but I just want to add one more product in the same line so that it can also be processed within the same time duration. That's a more flexible way of doing an operation. Okay, I'll tell you another good example. At times you drive car, you speak to somebody over phone. Okay, so how is that possible? The reason is there is some technology involved in your car, like a Bluetooth or some typical connectivity, that is actually allowing you to speak to somebody over phone, but your phone and car are integrated. The way you are, the way you are integrating both the devices in order to perform an operation has brought that flexibility. Flexibility is you can drive and still speak, right? Now the third one is improved material handling and storage. So you get the materials, which are the finished products, and then you have to store them. The reason why you have to store them, you have to actually, it is used either for packing or maybe pre-packing also you can do, or post-packing also you can do. So for both the things you require material handling, at the same time storage. So you will get, so since 10 products are coming, so robot will wait until 10 comes, then it will just take away the thing. That could be a AGV, automated guided vehicle, which will actually transfer the material. Online inspection. Online inspection is you produce a product and simultaneously it is getting inspected. That means you are having a first or second levels, 2 levels of quality checks. Okay. So while transferring the materials also you can have a quality check, or inline also you can have a quality check. Okay. Process control and optimization. This is a very well known topic. So you produce one typical apparel in 10 minutes. Same thing, if I am automating, I can do it in 5 minutes. That is having a better process control and it is optimized. So the 9th and 10th things, the components of this automation strategy is, you have a plant control and it is integrated with a computer. So the reason why we are integrating with the computer, flexibility. You can view the plant process anywhere with the help of an internet or an IoT technology or any typical cloud based thing. Okay.